Good, good afternoon, everyone, and welcome to the third session of the Cambridge Disaster Research Network. I'm Milena. I'm one of the conveners of this research network, and I'm here just to present some of my colleagues that are involved in this unusual seminar, which is dedicated to the presentation of one of the research that the Cambridge Disaster Research Network will do with from a collaboration from another organization. There is the Cambridge Infrastructure Resilience Group. So today the theme will be lessons from a Cambridge Disaster Research Network and Cambridge Infrastructure Resilience Group, and based on stories and new methods of risk analysis. We do just a research starting from an historical disaster event, which is the 365 Cretan earthquake and tsunami. And we asked 5 groups of interdisciplinary researchers using 3 definitions of wars to build worst case scenarios. So the session of today will be organized like that. The first part of half an hour, 40 minutes will be based on the presentation from Camilla, Penney, and Hannah Baker from our 2 of the conveners of this group. And then after we will have a debate just from almost half an hour of debate. So you are very welcome to give us your feedback, comments, and discussion. So Camilla, you can start, and I will ask to all people to put off their microphone until the debate. Okay?
Yeah, cool. Thanks very much, Milena. And yeah, I'm pretty excited to be able to come, I guess, today and to present some work that's actually come out of this network. So it's a slightly unusual seminar, I guess, in that the work is not yet published, but it has resulted from this collaboration. And so it's kind of cool to be able to share it with you guys today. And also that we'd be very grateful for any feedback or comments, because yeah, it's still very much a work in progress. And also it's exciting because it's an opportunity to share with those of you who were involved in actually doing this workshop some of the things that we've come up with as a result of it. So yeah, thank you for being here. And also I'd just like to say thank you to the other people who worked on this project. So Hannah's going to speak to you later. Rory's joining us from Chile, and then we have Henri and Alex from the Cambridge Infrastructure Resilience Group, and they are not here at the moment, and also Sarah from our network as well, but they were all very much involved in making this study happen. So I thought I would start by just introducing a network that you probably all know because you're at a seminar by it, but this kind of collaboration came about because we wanted to do some work between the Cambridge Disaster Research Network, which is this group that brings together researchers across both the University of Cambridge and also with external practitioners who work on disasters, with Cambridge, which tries to do kind of a similar thing, the Cambridge Infrastructure Resilience Group. And so they're interested, I suppose, more a little bit in the kind of technological sides of risk and resilience. And so we've been kind of having a discussion about how we could do something that would bring the expertise from these groups together, and how we could leverage the idea that we were connecting people across different disciplines in the university. And so we arranged a meeting to see how we could do this collaboration. And basically I arrived at the meeting extremely excited because I had just read this paper by Gordon Wu, who we're grateful to have on the call today, about this new method in risk analysis called downward counterfactual analysis. And I'm going to talk in more detail about what this involves later, but just to give you some insight into how the project came about. The aim is to provide a scientific and systematic approach to creating scenarios, in Gordon's words. And specifically, the aim is to go beyond the historical record in anticipating what future risks might look like. And to look at potential high impact, low frequency disasters by basically investigating how historical disasters might have been worse. So the idea is that in contrast to normally what we might do after a disaster, where we say, what are the lessons learned? Could we have done this better? We say, how could this have been worse? And by doing so, try and identify areas where a disaster might have been averted just by luck, rather than because we've really planned for it properly. And so the technique has its origins in financial and insurance risk, and that will become important a bit later, but it's also been applied to thinking about a variety of hazards already. So I was very excited about this paper, and so this kind of sparked this collaboration. I'm not going to tell you the whole story chronologically, because that will not make the best and clearest explanation of what we've been doing. So to take a step backwards, let's just think a little bit about why risk analysis is something that we might do, and why it's something that bringing interdisciplinary perspectives to might be relevant. So understanding what might happen in the future and how likely different scenarios are is a game that a lot of people are interested in playing, right? So financial sectors, reinsurance, and also people involved in disaster risk reduction and humanitarian aid, like we heard about in our last seminar on anticipatory action and early warning systems. We want to understand what might go wrong in the future and how we could best deal with it. And so the idea is that by understanding these possible scenarios, then we can do something about it. Crucially, when we're trying to understand those scenarios, the most important step is working out, the most important step of this risk analysis is working out what those scenarios might be, which to me is an inherently imaginative exercise, right? So it's thinking beyond what we might normally think about to understand what the things that we haven't really considered are. And this is somewhere where you can imagine that having two quite large interdisciplinary networks it might bring a useful contribution. So the other key point in this risk analysis is that what we're really interested in today, and one of the key problems of risk analysis in general, isn't really the kind of easily quantifiable modelable risks that you would know about kind of offhand. It's in understanding the events that are known as black swans, a term coined by Nicholas Taleb in 2007. And these events are rare catastrophic events which kind of fall outside the space of our models or our current understanding of what risk might be. I have quite a lot of opinions about black swans and what constitutes them, but I'm not going to bang on about them now. But the idea for today is that the kind of events that we're really interested in are scenarios that haven't previously been considered and that might go beyond what we're usually thinking about. So I mentioned that the technique we're using is called downward counterfactual analysis. And so a counterfactual is a reimagining of history. So I wanted to just start by briefly outlining some of the reasons why we might need to go beyond history in understanding what future risks exist. And I'm going to do that in two steps. So first is thinking about hazards. So this is a map of an earthquake hazard map from Pakistan. And what you can see is that it has these red spots in the areas where there have been relatively recent earthquakes. So Quetta in 1935, and then Kashmir in 2005, etc., etc. So perhaps one of the most obvious issues with understanding future hazards based on the historical record is really that our record is very short in comparison to the time between events. And that applies particularly to the instrumental record, so to anything that we've actually recorded. But there are other issues that are perhaps more subtle and less commonly acknowledged, I think, in hazard research. So, for example, whose voices are heard in the historical record? What constitutes good knowledge about a hazard? And also, can we interpret past indicators of a hazard event correctly, given our current scientific understanding of how that hazard works? And in any case, does the past provide a good reference for the future? It's an important question, both in recognizing aleatory uncertainty, so an imperceptibly different set of starting conditions, tiny changes in the rock structure at depth, might lead to a radically different event as the hazard unfolds. But also changes in climatic conditions, for example, might mean that the outcomes of a hazard event that happened in the past are completely different from those that happen today. And a good example of that is tsunamis, which is something that we'll speak more about later. And thinking about that, the effects of hazards and how they might change through time brings us to the kind of secondary and perhaps more difficult problem, which is the question about how we should think about disasters based on the historical record. So if we recognize that disasters aren't natural, but are the results of interactions of hazards and human societies, then we have to acknowledge that changing socio-political conditions raise questions about how the impacts of past events might reflect those in the future. And we have to think about how the same hazard event that's happened in the past occurring at the present day might have radically different outcomes. And in that sense, Ewing and Sinolakis pointed out, the key thing we need to do is to learn from past disasters, but not to plan specifically for them. On the other hand, there's a real danger, I think, and we all think, in framing disasters as unprecedented. So these are some examples from the current pandemic of where the COVID-19 has been framed as unprecedented. And this is really a kind of issue of levels of detail. So sure, the exact pandemic we're currently living through hasn't happened before, but does that mean that it was really unpredictable and unknowable in the way that these kind of headlines might actually imply? And so what these are being used to say is that we, and it's worth asking who we refers to in this situation, because it's probably not the epidemiologists in the room, couldn't possibly have known what might have happened, and therefore couldn't have done better at mitigating or preparing for it. So we kind of want to both avoid the overuse of the historical record and also framing it as a completely unuseful idea. And so that's kind of the starting off point for downward counterfactuals. So to give you an example of what constructing a downward counterfactual might do, which perhaps relates it to this kind of question of how we use the historical record, consider the Gorkha earthquake, which happened in Nepal in 2015. This earthquake killed about 10,000 people, so it was already a disaster, and it's caused long-term impacts as well. But the earthquake happened on a Saturday. And in Nepal, that's the only day when no children are at school and people don't go to work. And so we could consider a scenario, which you might say is vastly more likely, since the earthquake is more likely to have happened on any other day than a Saturday, in which the children were at school. And the hundreds of school buildings which collapsed in this earthquake killed children at school. And so that, in that sense, the earthquake could have been much worse. Also, the earthquake occurred to the west of Kathmandu, so it wasn't directly beneath the most populated area in this region. And we could imagine that it might well have ruptured slightly further to the east, and that would have caused significantly more death. Similarly, the scale of the earthquake, the event itself didn't actually reach all the way to the surface. And so that meant that ground shaking amplitudes were lower than they might otherwise have been. And so the destruction was less. Again, not particularly for any significant reason, not because we've prepared well for it, but just by a fluke, as it were. And then finally, socio-political factors. The earthquake happened in 2015, which was just towards a few years after the end of the Maoist insurgency in Nepal, when there was really significant socio-political tension. And so if this earthquake had happened a few years earlier, you might imagine that those effects might have been much more cascading and have led to much greater political instability. And so the aim of looking at a scenario like this, and I should say that that analysis is kind of focused on how casualties might have been worse, but you could think about making a scenario worse in terms of other things. So for example, financial losses or impacts on cultural heritage or other things like that. So the idea of this technique is to look at, it's basically to avoid the fallacy of assuming that a disaster didn't happen because we were well or properly prepared for it, and instead to interrogate what it is that we were lucky about when a near miss happened, or in this case, when a disaster happened. And it must be said that much of the tectonics literature in the context of this earthquake has spoken about that, right? Many of these particular examples I've given here are simply the luck of the draw in terms of how the earthquake developed. So where does our study fit in? Well, what we wanted to do was to think about introducing stories into these techniques. I mentioned before that downward counterfactual analysis was proposed in the context of financial risk and reinsurance. And so that involves looking at scenarios where you can quantify risks and quantify their probabilities and quantify their outcomes. However, the earliest work on trying to implement these methodologies suggested that one of the things that would be really important to capture is the stories of people involved in designing the scenarios and constructing the scenarios. And particularly, Gordon suggested that one might play this search exercise sequentially around a table, rather as in a Victorian parlour game, which is quite an appealing idea for involving an interdisciplinary network. So what we wanted to do was basically see whether we could find ways of introducing qualitative risks into this kind of primarily quantitative methodology. And in particular, what we wanted to do was to test a hypothesis, which I rather naively as a physical scientist came up with, which was that if we had used different groups and started with the same scenario, then kind of repetitions of similar turns or similar downward counterfactuals might tell us something about their relative probability. And I'll come back to why that was naive a bit later on in the talk. Okay, so the main data collection exercise that we did, which some of you were at, was a 2-hour workshop, which we held on the 22nd of March this year in 2021. And I'm just going to talk briefly about how that worked and what we actually did, and then what we did with the data as well. Okay, so we recruited our participants from CDRN and the IRG. And on the side here, I've shown a word cloud of how people self-described their disciplines and area of research. So clearly, most people were interested in risk, but it was basically people working on who were experts on different aspects of disasters. And we had 22 participants, so we divided them into 5 separate groups. And in terms of saying that we were talking about experts, most people were affiliated to Cambridge. Some also to other universities, and a couple from outside academia. So I've just shown here a pie chart showing the relative career stages of different people involved. So you can see we're mostly postdocs. And that's partly because I should say that when we say participants, the people who were authors on this paper also acted as both conveners of the workshop and participants in the exercise themselves. And so it must be said that though the group was diverse in terms of its disciplines, it wasn't diverse in terms of relationship to disasters or any other things like that. Yeah. And so what we did was we started with an historical event. So this is this 365 CE earthquake and tsunami, which is known to have occurred off the western coast of Crete. So where this white line is on the map. I don't know if you can see my mouse actually. Can you see my mouse? Yes, you can. Okay. Where this white line was on the map. And this earthquake was a magnitude 8 earthquake, and it triggered a tsunami which affected the whole of the Eastern Mediterranean. So the yellow dots here are regions which were impacted by that tsunami. So it already had significant effects in 365 CE. And the red lines here show, the red areas here show areas which are below 10 meters above sea level, so which are kind of vulnerable to tsunami inundation. And we are not the first people to point out that a similar earthquake happening at the present day would be likely to have really severe impacts across the Eastern Mediterranean. So on the right-hand side here, we've got a map of population density, and this is a logarithmic map, just showing that there's really an awful lot of people living in some of the areas of the Eastern Mediterranean that might be impacted, for example, particularly the Nile Delta. And so this kind of starting event that we were working from, this seed hazard event, was this earthquake, but happening at the present day. And we said present day in a sort of broad sense. And again, we'll come back later to why that might or might not have been a good idea. Okay, so this is a kind of a bit involved diagram, but just kind of to demonstrate what we actually did in the workshop. So we started with this earthquake transposed to the present day. And then basically we had these 5 groups of participants, and we took it in turns to have a go or make a turn. And the idea was that each participant would propose a turn which should make the event worse. And we did this 3 separate times. So in the first round, the idea was that it should make the event worse by making more casualties. In the second, that there should be greater financial losses. And in the third, that it was kind of up to the participants, but with a particular emphasis on exploring ideas that we hadn't talked about in the previous 2 rounds. And then the second thing that was kind of required of the events is that they should keep the likelihood of the event as close or as possible to the original event, or perhaps higher. And again, we'll talk a bit more about whether or not that happened later. And the end of what we were looking for was really a worst case scenario, and alternatively to reach a particular time limit. And so the idea was that in each group, someone would propose a turn, and they would say what type of turn it was, and I'll come back to that in a minute, and then why it was both downwards and also quite likely. And then the rest of the group could have a chat about it and say yes, no, and then carry on. In practice, it didn't really work out very much like this because it was a semi-structured conversation. And so there was kind of a lot of back and forth and various issues in terms of working out what was a turn, what was its consequence, who had actually proposed a turn, what type of turn was it, and all those things. So it turns out, and again, this is physical scientist naivety, that it's more complicated than you think actually talking to people. So just briefly in terms of what we did with that data, and this is the point where if you were at the workshop, you can wake up because now you won't know what we, now you won't know this bit. The first thing that we did was just to transcribe it. So we used the Zoom audio recordings with an automatic transcription software, and then each of the conveners of the groups manually checked their own transcription. And then the next step was codebook development. And just briefly for people who are in physical sciences, just to mention what coding actually is, because it's not Bash or Python. The idea is that you look through your kind of record of what people have said, and you highlight different sections and you tag them with what they're about. And so what we did was that we went through all of the transcripts and tried to identify what the themes were that had come up. So there were inductive and deductive components. So inductive coding is when you use the data to work out what the things that you should be tagging are. So you read it and say, oh, lots of people are talking about political instability here, I'll tag that. And deductive is when you have a pre-assigned notion of what the people are going to be talking about. So we did a bit of both of those. And yeah, we used some particular software to do this, and each of the rounds was coded by at least 2 of us. And you can imagine that when you do this, people might have different opinions on what it is that has actually been said or what people are talking about. And so to try and make sure that the results are robust, we wanted to do some intercoder comparison, so comparing how different people have coded it. The problem is that there are various automatic measures for doing this, but we had used quite an unstructured approach. So we hadn't predefined the units of length that we were coding. And then we also had like lots of codes that you could apply. And so what that means is that using automated measures doesn't really give you a good reflection of what people had done and how well they agree. So instead what we did was we went through manually, and when we were looking at each turn, we checked that we all agreed that that was a turn and what it was about and how we should assign it, basically. And in particular, we did that with the deductive coding, which was really about the types of turns that people were making. So we used 2 different systems to classify that. So the first was proposed in the same paper, which kind of codified the methodology for downward counterfactuals. And this was this kind of chart of 16 different ways that one might change an event to make it worse. And so they're kind of quite detailed and reasonably comprehensive, but we were interested in exploring whether or not they work as a way of thinking about these downward counterfactuals. And then the second set were broader, and they've been proposed by the Foresight team at Arup, they're an engineering consultancy, just kind of broadly classifying changes into socio-cultural, technological, economic, environmental, or political. And so we kind of wanted to explore the interactions between those. And then we also did inductive coding, and I appreciate this is a rather complicated diagram, but essentially this is just showing a kind of map of the themes that did emerge. So we had kind of 3 broad areas that we classified stuff into. So one was themes, so literally what was going on in the discussion, particularly thinking about things like, you know, critical infrastructure, tourism, other natural hazards, warning systems, trade, all those kind of things. So that's this grey box here, which shows some of those. And then the other thing was justification. So how did people back up that their turns that they were making were actually downwards? And how did they say that they were likely, given that we weren't actually making any quantitative calculations about them? And Hannah's going to talk more about that in a minute. And then the final thing was methodology. So that was where people were explicitly saying things about how we were conducting this exercise, how they would have liked the exercise to be conducted, but also smaller points which gave us some insight into the way that that exercise was working. So were people making shifts that followed on from what other people had said, or were they coming up with their own thing completely? Okay, so the part that you've probably all been most interested in, what did we actually find? Well, to start with, one of the things that we made and that I'll kind of introduce you to is for each of the groups in each of the rounds, we came up with a diagram like this, where we tried to map the conversation in terms of the turns that had been made. And so what we've got here, I'll just walk you through it. So this is from the financial round. And essentially what we've done is I've numbered the turns that people suggested. So in this case, we started with the loss of infrastructure. Somebody proposed that, you know, this earthquake happens, we're going to lose infrastructure in cities. That's a problem. And then the second person says that actually this disaster would be worse if there were rumors spread on social media that billionaires had died in the region, right? That's going to cause financial instability. And so what we've done here is showing that these are independent terms, right? The loss of infrastructure doesn't impact the likelihood, particularly, of rumors on social media. But then if we look at the third turn, someone proposed that if there's an additional rumor that the event was in fact fake news, you can tell whose presidency we were coming out of at the time, and then there might be a lack of US aid for the response, right? And the reason, and that's connected, I would argue, to the previous turn, because it's related to kind of rumors and social media. And so you can kind of continue going through the exercise, looking at which turns carry on from previous ones and which ones are independent. And then the other thing you can do is that these little boxes at the bottom show what type of turn we've classified it as. So, for example, that rumors on social media would be cascading events. They follow on from the main event. But you can see also that there's maybe some disparities or questions about how you actually do that. You know, why is it that rumors that this is a fake news is socio-political as well as cascading? And a lot of that comes down to the actual context in which you read it. So they might not be as obvious from just the summary. And then the final thing we've done with this is these letters here, which are where a turn is repeated, either between groups or between rounds. And so, for example, in this case, we said that the shifting the epicenter further east might mean that this event impacts the Suez Canal. And actually that came up in almost every group in the financial. Interesting. But so there's a particular letter that corresponds to impacts on the Suez Canal. And so this just allows us to draw some conclusions between groups and pick up on what those things are that are similar and what things are different. So that's an example from the financial round. And then this is an example from the participants' choice round. So that this kind of final throw it all in and think about what other things might be going on there. And you can see that then there's quite a lot of variety in the type of thinking. So there's things about China solidifying its influence in Southern Europe, the potential for misinformation in the wake of a disaster. And you can also see that some of these things are really pretty hard to quantify, which I think is quite important when we're thinking about what the value is of including this kind of storytelling in downward counterfactual analysis. So in terms of then classifying what it was that people were actually talking about, this is just a heat map of coding counselor themes. So this is just the number of times that different themes that we identified came up. And I guess I just wanted to point out really that it is somewhat dependent on the round, but there are also similarities between groups. So the most common ones are critical infrastructure, which is kind of subdivided. So there's things about water infrastructure, power, shipping, roads, and other natural hazards. So that was often landslides or infectious diseases, which I'll come back to in a moment. But then that they've also changed throughout the round. So for example, political breakdown was much more widely discussed in financial and participants' choice rounds than it was in terms of casualties, whereas something like warning systems was much more common in the casualties round. And I should say also, this is a bit of a whistle-stop tour. If anyone has specific questions about any of it, we're very happy to talk about it more. So one thing that we spent quite a lot of time on was turn types. And this was partly because it's something that is kind of, in a sense, I suppose, quantifiable out of the qualitative, in that we could do our deductive coding and identify what it was that people were changing about the scenario, and then look at what the relative frequency of that was. And so the chart on the left here shows the different turn types that were proposed by Lynn et al. And then the blue bars are the total number of that turn type. So the blue section corresponds to the number of times that was coded with another turn type as well. So it's not just a cascading event, but also some other type of event. And then the orange bars show when it was just a turn on its own. And so you can see that the most common thing is cascading events. And we think that that's quite interesting because it suggests that people are viewing the scenario as developing temporally from the hazard event being the kind of start point, both in terms of the part of the scenario which is actually connected to the historical reality, but also perhaps in terms of what constitutes a disaster, right? That there's some kind of triggering event. And that's potentially a criticism of this methodology in terms of thinking about the idea that actually the disaster results from the pre-existing conditions interacting with the hazard itself. So one thing we can notice here is that events that are just to do with the hazard, changes that are just to do with the hazard, are actually relatively uncommon in our analysis. So I've circled them in red here. And if we look at the picture on the right, which shows us where we've coded them with more than one turn type and the number of times that's happened, then you can see that where we have, say, timing, that is very commonly interacting with exposure. So that would be something like a shift that looks like, oh, the earthquake would be worse if it happened in summer, and that's because there would be more tourists on the beach. So it's not enough that the earthquake itself has changed time, it's also that you have to have the additional exposure of tourists for that to be a relevant change to make. So yeah, that was quite interesting because it suggested that the social factors were coming in more in terms of what people were trying to change to make this worse. You can also look just briefly at the Arup drivers of change, this kind of simpler classification. And there again, we see that sociocultural changes are the most common ones. And we think that environmental is also pretty common just because that encompasses everything that's to do with the hazard effectively, as well as other conditions around, you know, has there been rainfall before the event and things like that. And one thing that we did find that was quite interesting is that neither of these classification systems fully captures or simply captures every turn that people make, but there are some trade-offs in that things that are quite easily classified into one of these categories are often much harder to classify into a more precise category, as proposed by Lena et al. And so just finally, before I pass on to Hannah, something that I found pretty exciting about this. So I said that I had naively hypothesized that the most frequently repeated turns might be the ones which were most likely to actually happen. And so what I've shown here is a plot of the turns which happened most frequently. And I was surprised, but perhaps I shouldn't have been, that when we plotted this up, the top thing that comes out is time relative to a pandemic. And you can imagine that during March 2021, this was at the top of many people's minds. And you can see that this has come up in the casualties round, the participants' choice round, the financial round. What people didn't agree on is what time relative to a pandemic would be worse. So there were some suggestions that it would be worse if the event happened in a pandemic, some suggestions that it would be worse if it happened just after a pandemic when everyone wanted to go to the beach, all those kind of questions. But the point here is that, and Hannah will return to this later, is that what people are really thinking about is stuff that is present in their minds at the time, right? And similarly, the breakdown of the EU was something that came up kind of repeatedly, both either in response to turns that were being made or as a precondition that would cause more difficulties in terms of disaster response. And again, that we think is likely to be to do with the timing and geographical location of the majority of the participants. One thing that I just want to note quickly is this idea of the blockage of the Suez Canal, which came up in a large number of groups, particularly in the financial round. And this is kind of interesting because our workshop was hosted on the 22nd of March, and we woke up the following morning to find that the Ever Given was now stranded in the Suez Canal. Which is not to say that this analysis particularly was, you know, predictive or anything useful, but that analysis did lead to the idea of various things. You know, we came up with food shortages as a result of that, global breakdowns of, you know, financial systems and things like that. And so there are ways in which you could view some of this analysis also as a downward counterfactual for what happened in the Suez Canal as well, I think. Although that also leads to questions which we won't really have time to go into now, but I'd be happy to answer questions on about the way that causality is kind of implied by the simplistic way that we take turns in this game, as it were. So I'm going to pass on to Hannah now to tell us a bit more about the ways that people justified their turns.
Thank you. So yeah, as Camilla mentioned there at the start, one of the things which came out of the inductive analysis that we did was this justification of the turn types. And one of the most common forms of justifications that we found was this use of case studies. So it's people referring to specific events that had happened and drawing on their understanding of that. So as shown on this slide, we identified 42 unique events from the transcripts, and these varied in terms of their type. So the most common were previous earthquake events, but we also saw people referring to previous volcanic eruptions, hurricanes, and as Camilla mentioned, pandemics, and then also non-natural hazard events, including conflict, terrorism, and economic crashes. And so these varied in terms of their geographical location, also the time, with the majority happening post the millennium, which I'll get back to in a second. When focusing on specific events, you can see here that the most common was COVID-19, the Tohoku earthquake, Brexit, Beirut's explosion, and the Indian Ocean tsunami. So if we go on to the next slide, so we're using this slide just as an example of how case studies were used to justify a term. So in this case, you can see that the second speaker is drawing on their knowledge of the Haiti earthquake to explain what the impact of losing the road network could be, which was a term proposed by one of the other members of that group. So what's also good about this quotation from our perspective, it shows the benefits of having a range of expertise within a group and that discussion to build up a scenario. So on to the next slide. So the prevalence of these case studies led us to propose a term which is counterfactual chimeras to describe the resulting scenarios. So in Greek mythology, a chimera is a monster which is composed of the most fearsome parts of several animals. So these usually being a lion, a goat, a serpent, or a dragon. And similar to the scenarios which were developed in our workshop, these had a mythical quality in terms of that they haven't occurred yet, but they're also often composed of the worst aspects of previous disasters. And so there is a balance to be drawn here, and there was a comment made in the workshop that I'm now going to read out, and they said, I was drawing way more on real world examples I previously knew about rather than thinking outside the box. And I felt that there was a tension between trying to think of something that makes it worse whilst also trying to keep it believable. So on to the next slide. One of the issues with the case studies was that, as I mentioned and Camilla mentioned, the majority of the events that were referred to happened after the millennium. So an issue here is what Kalman calls tempophilia, meaning that there's the prioritization of current time in thinking about future and potential futures. So what's in the news, and this heightens awareness and potential bias in the scenarios being posed. And we saw this again, as been mentioned, through the mention of COVID-19 and time relative to the pandemic. So we said that if we had conducted this workshop before COVID-19 happened, that it would probably be highly unlikely that there would have been such a strong focus on pandemics in the workshops that we conducted. And so such a focus on current events and why it's a limitation can limit the range of scenarios which are considered. And one approach that we could use to avoid this bias and the use of contemporary analogues would be to encourage participants to draw on less well-known examples. However, that being said, we're not dismissing the use of the recent news or lived experiences, and it was still vital input into the exercise. So just on to the next one, thank you. So as a couple of challenges also to highlight, which have been touched on already, is one is what does worse look like in a qualitative context? So as Camilla has already mentioned, there's limitations with quantifying some of the impacts and turns that came out of the scenarios that we built up. For example, the loss of heritage, and then also, yeah, I think it was mentioned, the impact of China's, if China had a strong impact in the Western culture, and how on earth do we quantify these and how do we compare them? And so this actually reflects a sort of wider issue with quantification in risk analysis, and it's something that we'd like to bring up in the discussion with you, and would like to hear your viewpoints. So on to the next one. And another challenge or a question that we had ties in with what I've just mentioned is actually worse for whom. So we deliberately left this area open because we wanted to see what people decided to focus on. And as shown on the diagrams that Camilla showed earlier, there was a range of possible scenarios which were proposed, and also a variety of scales. So the example just here is that in the financial realm, people talked about damage to individual super yachts, but also talked about the crash of the euro. And so these are both forms of economic damage, but they clearly have different scales and affect different people. And so just to round up with the last slide from me, one of the benefits that we really would like to highlight from the workshop that we did was this use of interdisciplinary groups. So as shown in the quote earlier and on this slide, there were examples where someone could ask a question or use the expertise of others in the group. We also saw examples where participants were using their own disciplinary expertise to challenge terms either as implausible or unlikely to make the scenario worse. And we think that such interactions support the idea that a group discussion provides a greater diversity and depth of knowledge than an individual person or a group of people from the same discipline conducting this exercise on their own. And one critique of our own workshops was that perhaps they were too small in terms of group size, and we could have had even more diversity of expertise within them. Several participants also commented on the importance of including local stakeholders, such as residents or civil protection agencies, and this would better understand the complex factors leading to disasters in that particular area, which ties in with the last point I'm going to make, which we think that this exercise could be useful for education purposes of bringing people together. And as mentioned earlier, because there are limitations in quantifying stories, instead we argue that becoming familiar with multiple narratives and forms of knowledge will actually lead to improved risk analysis in that way. So I'll pass over to Camilla just to give you some conclusions and round up.
Thanks very much, Hannah. Yeah, so I'm just going to conclude briefly, just to say that yeah, we've done this, and it was a really cool way to meet other people in these networks and to bring people together. One of the most obvious conclusions is that if a similar earthquake to this one happens today, it's very likely that there will be a disaster, and it's possible that the consequences of that might be quite a lot further reaching than the kind of analysis that has previously been done on this earthquake, which has tended to focus either on specific locations or on specific sectors. And so it would be worth thinking carefully about how we consider the interactions between those different forms of risk. We've all spoken about the idea that there's been a strong focus on kind of current events and that what comes up most frequently might not be what is most likely to occur. But it is true that some of these areas that we know about also highlight areas which we know to be the regions of vulnerability. For example, refugee camps being frequently mentioned doesn't mean that that's not something that we should be considering and planning for such an event. The focus on cascading events suggests that downward counterfactual analysis does tend to kind of center the hazard event in approach to disasters, and that's something that we can think about how to mitigate. And mostly, I kind of wanted to end by saying that there's a question about what we've missed here, and the answer is probably the next black swan, in the sense that Taleb defines a black swan as something where nothing in the past can convincingly point to it. And so what I would argue we're doing in doing this kind of exercise is perhaps reducing the space for black swans to exist in, rather than in fact eliminating them completely. So just to finish there, I just wanted to say thank you very, very much to everyone who was involved in the workshop, and also to the members of this network and the infrastructure resilience group for participating and generally providing us with an interesting discussion space for this kind of work. So thank you very much.
Thank you, Camilla. Thank you, Hannah. Brilliant presentation. So you are all